Hi everyone, and welcome to today's Physics Daily Booster. This is number 17 in our Paper 2 series, and even though it is not listed on the advanced information for either the foundation or the higher tier physics, as we found out on previous papers, that doesn't mean that questions won't come up, because as it tells us on the advanced information, there is no information that will not be assessed. What we're going to do then is carry on our journey through space, and the first thing we're going to consider is a satellite. When we think about satellites, these are either going to be classified as natural or artificial. Natural satellites are made of the same material as the rest of the objects in the solar system, so they're things like our moon, for example. And artificial satellites are the ones that we as humans have sent into orbit around objects like the sun or planets. So natural, naturally occurring like moons. Artificial, these are the ones that we've created and then sent up into space around planets, sun, etc. In terms of what we can do with our satellites, we need to understand that there are two types of orbit that these satellites can occur in around Earth itself. We've got geostationary orbit or low polar orbits. If we look at the little diagram in the bottom left, we'll see the difference here. If we look at the geostationary first of all, that is the larger orange circle going around here, okay? So what we can see is that our geostationary orbit, this one is actually going to have our satellite, there it is, at a fixed position above the Earth. The reason for that is that the satellite orbits Earth once every 24 hours, Earth spins on its axis once every 24 hours. So think about the word, we're split it into two, geo, meaning Earth, stationary, not moving. So basically it stays above the same point on planet Earth. If we then look at the low polar orbit, which is a bit harder to see, it's the one that's coming round here, then this one is much closer to the Earth as we can see, and it's going above the two poles, okay, hence low polar. What we need to be able to do is then compare these two types of orbit. So geostationary first of all, as we've said, it takes 24 hours for a single orbit to occur. They are much higher above the Earth's surface at around 36,000 kilometers, and the key feature about it is it's going to remain in that fixed position above the Earth's equator. In terms of what we use these geostationary orbited satellites for, then it's things like our communication satellite TV, because what we want to do is know exactly where we're actually transmitting those signals in terms of where that satellite is. So if it's in that fixed position above the Earth at all times, we know exactly where the signals are going to be bounced and therefore what direction your dishes need to be orientated to collect the signal as it returns. Low polar orbit though, this one has a much shorter time to orbit, only about 2 hours, much closer to the surface of the Earth, only about 2,000 kilometers from the surface there, and its key feature, as we saw on the diagram, it orbits over the poles. Now because this one orbits once every approximately 2 hours, then we tend to use these for things like weather observations, spy satellites, because that means that every couple of hours you're getting an updated picture on what's happening here on Earth. So it means that we can do things like track troop movements. We can then watch as hurricanes move across the oceans and where they're likely to then hit. In terms of the types of orbit that we find, what we're really aiming for is a stable orbit. Now, stable orbits will occur when the object is moving at the right speed for the distance it is from the object that it orbits, i.e. it is moving at the right speed for the distance it is from planet Earth. That means it's going to remain at that steady position. If we think about some of these natural things, like our planets for example, they are orbiting the sun. So what we find is that as we go further away from the sun through our solar system, our planets are moving slower. So the ones closest to the sun moving quicker, the ones further away moving much slower. And the reason for this is all down to good old gravity once more. Because the further from the sun we are, the lower the pull of gravity will be. So what we find is that there's only a small force changing the velocity of that individual planet. So as a result, it moves at a slower pace. The reason that's important is that if, for whatever reason, and this is very much a theoretical thing here, folks, if we were to have Neptune as our planet in the outer reaches of our solar system start to speed up for some reason, then what we would find is that the gravitational force that the Sun has on Neptune would not be sufficient to keep it in orbit. So Neptune would then go flying off into the outer reaches of space. Not great, because obviously all the planets have these little gravitational links between them, and it would wreak havoc with the rest of our solar system. If we think about the opposite, if Neptune was to randomly slow down for some reason, then what we would find there is that the gravitational pull from the Sun would be enough to accelerate it towards the Sun itself. Again, not really what we want to see happening. We don't generally want giant planets to come hurtling towards the Sun through the other ones in our solar system. Luckily, two very theoretical principles there, but it does go to show that the reason that these planets have a stable orbit is because they are moving at the right speed for the distance they are from the Sun itself. As always, if there are bits from today's Daily Booster that you'd like to go over in a bit more detail, you can use the P8 playlist on the channel, use your revision guides, and of course have a look at some of those past exam papers on the OCR website, just to really get a feel for the type of questions. Then don't forget to join us tomorrow for the final Daily Booster of the entire exam season. I know we're all thrilled, we have almost made it, one more to go. See you tomorrow.